All right. So we are in 1.4, and the title of this section is called Measure and Classify Angles. And so we are really getting into the foundational concepts for geometry, and one of those starts with this term angles. Okay, now I don't know if you've heard of this term before, but just as an intro, we are going to start by drawing some angles. Okay, so draw an angle. Okay. So draw an angle and analyze its building blocks. So maybe when you think of angles, you think of like the corner of something, right? Yeah, and maybe you think of some of the shapes that you've seen, and then the places where the two sides meet. So, I mean, at its simplest, we would say that an angle looks something like this. Okay, and then it's not enough just to do that, but we want to analyze the building blocks. So, for example, we've talked about things like points. We've talked about things like lines, segments, rays, and planes as being the building blocks of geometry. And so even when we look at an angle, we can see that there are two rays that are heading this way, right? And then there's also another ray here that heads this way, and they're connected at their endpoint. So they are connected at this term called a point, okay? And so what we would say is an angle is built up of two rays connected at their endpoint. And an angle is always, well, an angle, to be specific, is this part right here. Okay, so this itself is an angle. And so an angle, couple things, it can vary in size. And then it is measured. And for now, this is all we need to know, is that it is measured in this term called degrees. And degrees being, well, the degrees changing by the size of the angle. So for example, 30 degrees, 45 degrees, 90 degrees, etc. Okay? So the next part of our notes is to consider how we name angles. Okay, so how do you name an angle? So for example, you wouldn't say that all of your teachers are just teacher and teacher and teacher and teacher, right? But you would say that your math teacher is Mr. Koo, your English teacher is someone else, your science teacher is somebody else, like that. And so we all have names, right? And in the same way, we can name angles. So here's one way that we can name an angle. So there's one of two. So option one is to name it by just calling it angle and then like B, for example. Or to write that a different way, this symbol right here, and then that letter right after it. So this is pronounced angle. And keep in mind that the angle goes like that, and then it has to be horizontal, okay? So one way to name it is by just calling it one letter, one capital letter, angle B. So an example of that would be like this. Okay, and so this guy we would call angle B, okay, or angle B. But here's where you're going to run into some problems. Okay, what if you had something like this? So here's angle B. And if I say to you angle B in this case, right, we have there's different kinds of options for angle B, right? So, for example, this could be angle B. Right? This could be angle B. Right? Or even this entire thing right here, this entire angle, could also be angle B. So that's when we have to get more specific with our names. And so that's the second option here, which is probably the best one. So option 2 is to use 3 letters or points. To use 3 letters or points. Okay, so if I can just give us an example here. If we are given something like this, and notice we have some points here. Okay, points A, points B, and points C. There's a few options that I want to present to you, and then I want to see if you can name it. So for example, I could call it ABC, angle ABC, or I can call it angle BCA. Okay, or I could call it angle CAB. Okay, or I can call it angle CBA. I could call it angle BAC, or I call it angle ACB. So these are not all the names, but these are some options. And so I want to think about that a little bit. And really the question is circle the options that are the true names. Of the angle. Okay. And so as we glance at this and we do a little bit of, okay, so A, B, C. So A is here, B is here, C is here. So that looks okay. And then I notice that the order here, BCA, okay, so BC, and then I'm kind of jumping over to A. And then CAB, I'm here, and then I jump over to A, and I go to B. And then CBA, I start at C, I work my way backwards, and I go here. And then BAC, I go like this, but I have to jump again. And then ACB, also I'm jumping. So notice that out of these guys, this one jumps, this one jumps, this one jumps, this one jumps, meaning that I hop from A to C or C to A. And so what that tells me here is that the best options probably are this one, angle ABC, and then this one, angle CBA. Okay, and so what do we notice here? That the vertex, and did I use the word vertex here? Oh, I didn't. Okay, so just to backtrack a little bit on our notes, this angle is called the vertex. Okay, so the vertex is the middle letter, right? So angle B, the vertex, is in fact the middle letter. And so the way that we would name it is angle ABC or angle CBA. Okay? All right. So now, what are the different types of angles that we have? So what we're going to do is we're going to draw a quick chart. So this section is called types of angles. Okay, and then we're going to draw a quick chart. So this first type of angle is called an acute angle. And I would like for you to underline that word, cute. Cute. And then our second type of angle is called a right angle. Our third type of angle is called an obtuse angle. And then our fourth type of angle is called a straight angle. So up to this point, with the angles that we've drawn, right, we might think of things like this, for example. But did you know that angles can have all types of shapes? And they can be all different types of sizes. And based off of the size, we can name these angles what they are. So one question that I like to ask my students is to name some things that are cute. And most students, and I ask them to keep it appropriate as well, but most people will say that things like babies, puppies, any type of little, right? Maybe some otters, right? Any type of little tiny baby-like things, these are the ones that are cute, right? We wouldn't look at an elephant and say that it's cute. We wouldn't look at a monster and say that it's cute, right? So, and acute angles are the cute angles. They're the ones that are little. They're the ones that are small. And so what do I mean by that? The angles here are little. Okay, so here are some examples. And you might be wondering, okay, I get what he's doing. Maybe he's drawing the angles really small on my on the paper. But it's actually not that. It has to do with this vertex right here. And see how small they are? Okay. So they look pretty small. So the question is, how small are they for them to be acute? And the answer is this. They have to be less than 90 degrees. They have to be less than 90 degrees for them to be considered acute. Okay? And maybe you're wondering, okay, so what is 90 degrees then? Well, if you have, for example, a sheet of paper has 4 90-degree angles, right here, right here, right here, and right here. And so you can see that these angles are way smaller than the 90 degrees that we have right here. You see that? Okay, so it's way smaller. And so the right angle is actually the name of the angles that equal 90 degrees exactly. And so there's only one option for it to be 90 degrees. One of the rays has to be going like this, and then one of them has to be exactly like perpendicular. Well, the fancy word is perpendicular, but it has to hit it in this way. And even for those of you that were doing the Pythagorean theorem, the Google Maps assignment, it's hard to get it exactly equal to 90, right? Like you have to get it right at the perfect angle. Otherwise, it's going to either be 89 or 91, so on and so forth. And this symbol right here, this symbol tells us that it's 90 degrees. Okay? And that symbol is the right angle symbol. So 90 degrees is kind of like the threshold. It's the place where things change. So anytime it's less than 90 degrees, it's going to be acute. It's going to be so cute. It's so little. And then right when it hits 90 degrees, it's going to be a right angle. And then anytime it goes over 90 degrees, well, and then it has to also be less than 180 though. So anytime it goes over 90 degrees, but is less than 180, this would be called an obtuse angle. So, for example, if we have this, and then notice the angle here is bigger than a right angle, because if it was a right angle, it would have just gone straight up, right? But it went over. See, it would have gone straight up, but instead it went over this way, and so that's what we call an obtuse angle. Okay, so some other examples here. So there's another one, right? So there's only so many ways to really draw obtuse angles, but there they are. Okay, bigger than 90 degrees, less than 180. And then our last angle is called a straight angle. So that word straight gives us a hint as to what this angle would look like. A straight angle would start at one end and then it would connect with the point, and then the other end would continue on exactly in the same direction. And so this right here, we would say is equal to 180 degrees. Even here, equal to 90 degrees. Okay, so why is that equal to 180 degrees? Well, if we were to cut it down the middle, we know that this right here is 90 degrees, and then we know that this right here is 90 degrees. So 290 degrees makes 180 degrees. Or even if you can imagine like a skateboarder, oops. Okay, so even if you can imagine someone riding a skateboard, right? And then when they, I don't know, hop into the air, whatever, then, so if this is a front and this is a back, then they might flip the board like that. So this becomes a front and this becomes a back. So what they've essentially done with their board is they flipped it from front to back to front to back. Right? And that would be a 180 degree flip. Okay? So that's 180 degrees. So the four types of angles. The acute angle, the right angle, the obtuse angle, and then the straight angle. Okay? All right, for our next section, I'm going to introduce to you guys something called the angle addition postulate. And so this is similar to segment addition. Postulate. But instead of using segments, line segments, we're using angles. So for instance, with the segment addition postulate, if you had something like point Q, R, and S, one thing we said by the segment addition postulate was this, that QR plus RS equals QS, right? And that was our segment addition postulate. Well, with angle addition postulate, it's pretty much the same thing. So if we have an angle like this, let's say it's cut like that, okay, so what are the parts of this angle? Well, we might say that this is one part, maybe this is another part, and then this entire thing from here to here is the third part, is the whole, right? So part, whole, part, whole. So how do we write that? Well, so far we've learned to name our guys like this. But just like with segment addition, right, we were not allowed to write it like this. Segment QR plus segment QRS is equal to segment QS. Instead, when it comes to the measures, we take off the segment symbol and then we just write it like that. And so in the same way with the angles, we do have to change it up a little bit. So instead of writing it like this, it must be written in this way. So anytime we work with the numbers, the degree measurements, we would write this in this way. So it would be written M angle AXB plus M angle BXC equals M angle AXC. And the way you pronounce this letter M, it's pronounced the measure of. Okay, so the measure of angle AXB plus a measure of angle BXC equals a measure of angle AXC. So anytime we have problems with numbers, problems with degree measurements, we want to use this way of writing things out. Okay, and so just a quick example for us. Okay, so just a quick example. So let's say we are given something like this. should correct this. It should be not an M, but an N. Okay, and let's say we are told that this is 10x minus 5. And then see that symbol right there? That tells us that it's an angle problem. Okay, so this symbol right here is degrees. So we know this is an angle problem, not a segment problem, but an angle one. And then the second measurement that's given to us here is 4x plus 3 degrees. Okay, so now the question would be, find x. Maybe in some of your IXL problems, you would see find the measure of angle NLM. So let's do this. Let's find x, and then let's also find the measure of angle NLM. Okay, so let's do those two parts. So the first part, to find x. So one thing we might do when we look at this, we might look at this, analyze this angle and see that, okay, this right here is a straight angle. And we know that straight angle, it's always equal to 180 degrees no matter what. And so that shows us how the angle addition postulate would work here, that this first angle plus this second angle has to equal to my third angle here, which is 180 degrees. So to set this up, I would say 10x minus 5 degrees plus, oh, you know what? Let's go ahead and set it up as angle addition postulate first. So we would say this, that the measure of angle KLM, KLN, plus the measure of angle NLM is equal to 180 degrees. Okay. Oh, I'm sorry. I'm rushing to measure of angle KLM. There we go. That's much better. So then what we can do next is we can go ahead and replace everything. So 10x minus 5 plus 4x plus 3 equals 180. Okay, and notice I've taken off my degree symbol. That's okay as long as at the end I remember to stick it back on. But from here now we do a little bit of algebra. So we can get rid of the parentheses because we don't see any negative symbols that would mess with it. So we're happy with the 10x minus 5. We're happy with the 4x plus 3. And we know that has to equal to 180. And then from here, we can combine like terms. So all the numbers, all the terms that have letters in them, we combine them. And then all the numbers that are alone, we combine them. Okay, so we work on one side first. So 10x and 4x added together is going to give us 14x. And then negative 5 plus 3 is equal to negative 2 equals 180. And then we just work it out. Okay, we add 2 here, we add 2 here. So 14x equals 182. And then from here on out, I just need to do a little bit of division. So 14x equals 182, divide by 14, divide by 14, x equals, and then this is 13. So that's my answer. So there's my first guy. Okay, now the second question asked me to find angle NLM. And all I know from this is that this has to equal to 4x plus 3, right? And given that my x here is equal to 13, right, what that means is wherever I see an x, since it's equal, it's the same, I can take that 13 and I can replace it for x. So this gives me 4. And then when there's no symbol in between them, that means we're multiplying. So 4 times 13 plus 3, which is 52 plus 3, which is equal to 55 degrees. And so that's the measure of angle NLM. Okay, so I'm done with my second part. So 55, and then even this guy would here would be 125. And if we just do a quick check just to make sure. So let's take our x equals 13 and put that into here. So 10 times 13 minus 5, 130 minus 5, 125 degrees is my answer. So I know that angle 1 is 125 degrees. I know that angle 2 is 55 degrees. And so at the end of the day, when I add 125 degrees to 55, I end up getting 180 degrees, which is the straight angle that we started out with. Okay? All right, and then just the last thing real quickly that I just wanted to add to these notes is this new term that we're going to introduce called a bisector. Okay, so, and more specifically, we're going to call it an angle bisector. So one thing you're going to see a lot is this verb, bisect. Right? And if you know root words a little bit, sect means to cut, and then bi means two. So we're cutting it into two parts, but more specifically, this means that we're cutting it into two equal parts. So if we expand that to include the word angle, an angle bisector is one that cuts an angle into two equal parts. So let me just label these points. So let's call this guy X, Y, W, Z. Okay, and then if we say ray YW bisects angle XYZ, then what that tells us is that it cuts this into two equal parts. So that means that so this means that angle XYW is congruent to angle WYZ. Or another way to put it is that the measure of angle XYW equals the measure of WYZ. Okay. So for example, in this problem, and then this will be the last one, if they said that the measure of angle XYW is equal to 18 degrees, then there's a lot that we can say about this problem. So for example, if they said find measure of angle X, Y, Z. So one thing we know here is that this is 18 degrees. And then the other thing we know here is that since it bisects, it cuts it into two equal parts. So if that's 18, this also has to be 18. And so the measure of angle XYZ has to be equal to the measure of angle XYW plus the measure of angle WYZ, which means that it's 18 plus 18, and that tells me that the answer for this angle is 36 degrees. And so the angle bisector is kind of like the midpoint that we just learned for segments, right? It's very similar to that, okay? All right, I think that should be enough information for 1.4. So good luck. So let me just flip through these pages one last time so we're all on the same page. Okay, there we go. 1.4, measure